Welcome to clickmyproject.com. Let we discuss about the process, a kernel clustering algorithm with fuzzy factor application to SAR image segmentation. Let us see the abstract of the process. Segmentation of images refers to extraction of the needed regions from the images, which is based on specified methodologies. The segmentation methodologies were commonly based on thresholding, that is, the regions within the particular range or pixels that are having particular values were extracted. Edge detection, contour detection, clustering were all common segmentation methodologies. Here we choose clustering for the clustering of the satellite images even in the presence of noises. Clustering refers to the protection of separate identification, or that is color difference or contour differences for the images in the for the regions in the images that are having similar intensities or similar colors. The clustering based methodologies segments the regions by grouping the pixels. The, the clustering methodologies provide accurate results in most of the cases, but in the presence of noises, some of the methods may have affected. So we propose fuzzy C-means based segmentation method for clustering based segmentation method. The number of clusters were determined automatically. The images are initially preprocessed using median filter and adaptive histogram equalization methodologies. The median filter replaces the identified noisy pixel in the images by the calculation of median of the neighboring pixels. The pre-processing step is the basic of all image processing methods. This method makes the images to make the overall intensity range in the images to a common size. Discrete cosine transformations were applied to the images in order to make the clustering more robust to noises. The discrete wavelet transformations were applied to the images in order to make the clustering process more robust to noises. The required regions are segmented from the preprocessed images using fuzzy C-means algorithm. Each pixels in the images were checked whether it satisfies the rules generated using the fuzzy logic, and if it satisfies means the segmentation process is employed. Finally, the inverse transformations is applied to the images and the clusters were obtained. Finally, the overall performances of the processes were measured in terms of accuracy of the proposed method. The calculated accuracy and the other performances metrics shows that the proposed method has higher accuracy compared to existing methodologies, since the fuzzy C-means methodology is more robust to noises. Let us see the flow of the process. In this process, the input images is first selected. After that, the preprocessing step is employed, which is based on median filtering. The median filtering normalizes the overall intensities in the images. After pre-processing, the images were decomposed based on discrete wavelet transformations. While applying discrete wavelet transformations, the coefficients were divided into 4 regions based on different types of the filters available for the specified wavelet in discrete transformations. After that, the fuzzy C-means clustering is applied for the low coefficient of the discrete wavelet transformation. The low coefficient of the discrete wavelet transformation contains the pixel informations in the images, and hence it is chosen for the clustering process. The low coefficient is then compared with the original image pixels, and after that the final clustering is matched. The low coefficient comparison is employed between the input image pixels and the cluster regions, and the comparisons is employed, and based on that the final cluster is assigned. This final cluster contains different regions of the input images. The input images were divided into several regions based on the different intensities in the images. The different intensities refers to the different representation of the colors, or else in gray images the different representations of the gray shades. Thus we are identifying the different regions in the images, and hence finally we measure the performance, which is calculated based on the calculation of accuracy of the overall process. Normally accuracy denotes the comparison of the resulting cluster with the predicted clustering values, so that the comparisons were done and the images were clustered to be of similar intensities. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process started. So first the browse option appears. So here we have given some remote sensing images and also some normal images. We can select any one of the images. So we select this image. So the process will getting executed. The complete results will be. So this is the input images that we have got. This is the pre-processed image. Comparing to the input image, the pre-processed image, the overall intensities of the images were smoothened. So then the pre-processed image is subjected to wavelet transformation, and this is the low coefficient obtained in the process. So the obtained low coefficients contains the pixel informations. So this information is then clustered. So after clustering of this original pixel information, we got the clusters for each color channels which is present in the image. Since we use color images, we apply the transformations for each of the color channels, and finally this is the final cluster that we have got. The final cluster represents the different intensity regions in the overall images. Finally, these are the performance measures that we have calculated. So this is the accuracy, this is the specificity, this is the sensitivity, and final overall error rate. These were all measured as the overall performances. Thus we have clustered the original images even in the presence of noises, and also we have measured the overall performances of the process. The clustering process is robust to the addition of noises in the input images. Thank you.